Okay, so I'm going to continue from where I stopped in the last video. So what we talked about description of the problem. Now, after the description of the problem comes the second step, which is analyzing the problem. Now, the purpose of this step is to determine both the starting point and the end point, the starting and the end point for solving the problem. Now, a good problem description make it easy to develop this step. If you've not done a good job of uh, um, within the first step, what we talk about the description of problem. If you don't have a good description of the problem, then there's no how you'll be able to do a good analysis of the problem. You must be able to know what's your entry point, what's your exit point. At what point can you say you achieved the solution? At what time would you say your algorithm, of course, which like we said earlier on, will translate to to the program? At what point will you see that you've achieved that? Now, when determining the starting point, we should start by seeking answers to the following question. What data are available? For example, the example I gave earlier on, that we want to develop an app that will recommend um meals for people. We're able to know what data are available. What kind of data can you even get at all? Can you say, okay, possibly you can get data like you can get people's physiological data like their height, their body shapes, and things like that. You can get their sex. Obviously, you'll be surprised that there are some meals that we like guys will like to eat and ladies don't like. Or and the other way around too. Please don't take my word for it. Okay. Um, other things like that may influence activities of the day. Are you a student? If you're a student, are you in science-based courses? Are you in sociology or social sciences? And like, or if you're in working class, what kind of work do you do? Are you a business person? Are you a white? Do you have a white collar? All of those are data. What kind of data? The moment a particular data that you need to solve a particular problem is not available, then you must revisit the problem, the decision of the problem, to understand what exactly you're supposed to do. I mean, you even don't understand the kind of data you will need for you to solve a particular problem. If you don't even understand the problem in the first place. Question is, the other one is, where is this data? How do you achieve this data? How do you get this data? Not all data, like, for although in the example I gave to you, the data that will solve that kind of problem are memory data that you can um, get by interviewing people. Yes, then you know that this data is with people. I have to start interviewing people. There are some other problems that the data are not readily are not with people. For example, if you need to work with Twitter or social media, you know that, okay, then you know that the data you need, you have to probably write to Twitter API to get those kind of data. What of if the data you're working, maybe develop an app for agriculture, then you know that the data available to you, you have is not going to be is going to be residents in agricultural farms, agricultural research institutes, and the likes. What formulas pertain to this problem? Like, once you're asking those kind of problems, that means you're moving on. That question is very, very, very crucial, because maybe to them, the formulas then tell you how you manipulate your data to give you the kind of result that you want. Next question is, what rules exist for working with the data? For example, if you're working with health data, you don't just use health data. You don't just go and get health data and start working with them. They will sue you. There's something called ethical clearance that you must obtain before you can work with health data. What if they give you data, health data of people, and somebody is HIV positive and just went ahead and start disclosing that, oh, this person is HIV positive? The person will really, really sue you. What Then another question is, what relationship exists among the data values. The relationship, this and the top point, what formula pertain to the problem and what relationship exists among data values are going to give you the result that you seek and that you need. Also, when analyzing the problem, when determining the end point, we need to describe the characteristics of the solution. Of course, it's when you know what kind of solutions that you need to be able to know at one point you've achieved the problem, and at that point you're going to exit. The following questions often help to determine the ending point. What new facts will we have? Hmm. What new facts will we have? At the end of the day, what your what your program will give to you is going to be new. What items will have changed? Because in terms of the data, what changes will have been made to those items and what things will no longer exist. Then we come to the third point, developing a high level algorithm. Don't forget, you've analyzed the problem, you've described the problem, you've analyzed the problem. So the next thing is developing a high level algorithm. Now, what's an high level algorithm? An algorithm, okay, an algorithm is a plan for solving a problem but plans come in several levels. It is usually better to start at a high level algorithm that includes the major parts of a solution but leaves the details until later. Now, that is a high level algorithm. A high level algorithm includes the major parts of a solution but leaves the details out. You don't need the details initially when you want to start developing an algorithm. Don't worry about the details. Don't worry about the complexities. Make it simple. What are the clear things you need? What are the exact things that you need to solve this particular problem? Now, for example, I have an example here. I need a pair of trousers. That's the problem. I just need a pair of trousers. Analysis. I need to buy a pair of trousers rather than tell a tailor to sew one because of time, nor make one myself since I do not know how to sew. Now, from what I taught you earlier on, I already knew where my data was coming from. Now, various sources of data could be. Now, don't forget that trouser is what I need, and I can get these trousers from either by telling a tailor to sew one for me, I decide to sew one for myself, or I buy. Now, by that, I already knew my possibilities. What are the things I needed? What are the things that will get me the things I needed? And what's my exit point? My exit point is the point where I have my trousers. Either way, any route I go to, the point where I have my trousers, that is my exit point. Now let's look at the high level algorithm. Go to a shop that sells clothes. Since don't forget that I've already doing my problem analysis, I already concluded that I'm gonna have to buy one since by myself I don't know how to sew. And I should tell a tailor to sew one for me. He's gonna go to the market to start buying the clothing material and start saying that may take maybe a couple of days to do. But if I need it right now. So my best bet is let me go and buy one. Now I level algorithm. Go to a shop that sells clothes. Clear? Don't forget high level algorithm. We're not adding the details. I, I don't want to say something there. Select a pair of trousers. Purchase the pair of trousers. Then I go back home. Now, from this example, this, this algorithm will actually get me my pair of trousers, but a lot of things are missing. For example, which shop do I want to go and get these trousers of mine? Where exactly is this shop located? How far is it from where I am? How many buses or cabs or bikes or how many liters of fuel will I have to or petrol yeah, for will I have to buy inside my car to get to this same point where I want to buy, why I want to get these trousers. Oh, okay, I'm already even getting into the third point. Third point, how will I get there? Do I want to walk? Do I want to drive? Do I want to ride my bicycle, or do I want to take the bus? Now look at it. The third question arose based on the answer for number two. Where exists shop? Now, if the shop is close by my house, I can decide that I want to walk to go and get these trousers. Or if it's gonna be, if it's a far place, I can drive. If it's not too far, I can ride my bike. If I don't want to, or maybe if I feel that okay, I don't feel like driving, which is another constraint now, I can say I want to take the bus. Then, what type of trousers do I want? That was never stated in the problem. I never said it's a denim I need, is a chino material, or just a small soft material that I need. All of those were never stated. Now, the next point, refine the algorithm by adding more details. Now, once I have, don't forget that high level algorithm just have the details. I don't want to care about too much of complexities at that point. Once something like a divide and conquer kind of thing, whereby I just separate my the problem into smaller parts that I can easily now tackle. Now, once I've separated it into smaller parts, I can then start tackling each of these parts by adding more details to this problem that will enable me to um solve each. Don't forget, at the end of it, I'm solving them one part after the other. By the time I've solved the last part, I will have achieved my aim. Now, high level algorithm shows the major steps that need to be followed to solve a problem. More details for solving the problem needs to be added for an effective and efficient solution. These are carried out by refining the algorithm. But how much detail do we have? That's the question. The answer depends on the situation. Whereby now we have to consider we have to consider things, who or what is going to implement the algorithm. All of those will define how we refine the algorithm. Don't forget, this refinement doesn't have to be done like in a single step. As a matter of fact, oftentimes your refinements can go in 4, 5 stages. Once you have a high level algorithm, the subsequent steps will spill over into multiple stages. This part is highly technical. How much that person or thing, how much does the person or thing already knows how to do? If someone is going to purchase the trouser on my behalf, my instructions have to be adapted to. Our goal is to develop algorithms that will lead to computer programs. Therefore, we need to consider the capabilities of the computer that will run the program. We must provide enough details so that someone else can use our algorithm to write a computer program that follows the steps in our algorithm. More details should be added to the algorithm instructions to achieve a data program. So all of these forms the refinement. Don't forget, at the end of the day, someone is going to implement this algorithm. If you've written an algorithm that only you understands, and you expect someone else to come and pick this algorithm and then implement it into using maybe Java or something, at the end of the day, it's not going to work because only you understood what you've written. Then again, don't forget the capability of the computer you want to work with. Don't forget, if you are writing a program that will be implemented on a computer program, of course, no, that will be implemented on a computer, then you can think of higher capabilities like okay, more storage, more RAM, more processor speed. But if you are writing a program that will be implemented on a mobile phone, you don't have the luxury of, may not necessarily have the luxury of all those processor speed and the like. So all of this you have to consider when refining the algorithm. I'm going to stop this video again for then we'll continue in another video. Hopefully that will be the last video for this class. Thank you.